Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss the statement and derivation of Pascal's law. Now, Pascal's law was given by a French scientist Blaise Pascal in 1653. This Pascal's law is related to the pressure acting on a static fluid. Now it states that intensity of pressure at any point of a static fluid remains same in all directions. That is, if a fluid is in static condition and a force is applied on the fluid or a pressure is applied on the fluid, then this pressure will be equally distributed in all the directions x, y, and z directions. This is a statement of Pascal's law. Now we see the application of Pascal's law generally in the hydraulic lifts which we use for carrying goods and passengers in multi-storied buildings. Now we will do the derivation of Pascal's law. So for proving Pascal's law, uh, Pascal's law states that intensity of pressure is same in all directions, but we will assume that no, intensity of pressure is different in all directions, and then finally we will prove that no, all the pressures which we had assumed different, they are same. So for deriving it, we will assume a small triangular fluid element whose dimensions in x, y, and z directions are dx, dy, and ds. The angle which ds makes with vertical is theta. Now let the thickness of fluid element be unity, that is 1. Let us assume that pressure in x, y, and z directions is px, py, and pz. So we can find out the force on any face. For pressure equal to force upon area, so force will be equal to pressure into area. Now from the diagram you can see that on the face AB we have the force Px into dy into 1. On the face BC we have the force Py into dx into 1. Similarly on face AC we have the force Pz into ds into 1. Now by the diagram you can see that this Pz into ds is inclined. It is making theta degree with horizontal, so we can resolve it in horizontal and vertical direction. So it will be pz ds cos theta in negative x direction and pz ds sin theta in negative y direction. Now one more force will be acting on this fluid element, which will be the weight of the element. Now weight is equal to mg, that is mass into gravitational acceleration. Now mass is given as density into volume, so we can write m equal to rho into v into g. Now volume can be written as area into thickness, and area of the triangular element is 1 by 2 base into height, so it will be density rho multiplied by 1 by 2 dx into dy into this will be the area and multiplied by g. So this will be the weight of the element. Now once we have achieved all the forces, since the fluid is in static condition, we can apply the conditions of equilibrium, that is sigma fx equal to 0 and sigma fy is equal to 0. So let us apply equation number 1, sigma fx equal to 0. It will give you px into dy minus pz into ds cos theta equal to 0. But from the diagram you can see that ds cos theta is equal to dy. So we can write it as px dy minus pz dy equal to 0, or px is equal to pz. This is equation number 1. Now applying the second equation, sum of all vertical forces equal to 0, the equation will be py dx minus pz ds sin theta minus half rho g dx dy is equal to 0. Now you can see that dx is a very small term, and when it is multiplied by dy, another small term, it can be neglected. So the weight of the element can be neglected. So we will have the equation py dx minus pz ds sine theta equal to 0. Now again from the diagram you can see ds sine theta is equal to dx. So we can write it as py dx minus pz dx equal to 0. That is py is equal to pz. Now from both these equations, equation number 1 and equation number 2, we can say that px is equal to py is equal to pz. That is the assumption which we made, that pressure intensity is different in all directions. That is wrong. Intensity of pressure in all directions will be same, which is equal to px equal to py and equal to pz. This is the derivation of Pascal's law. I hope you must have enjoyed the video. Thank you. Thank you everyone.